So I'm going to be working through this worksheet. You can find it on Canvas. And again, I would recommend that you print it off and kind of work through it as I work through it. So you can try a problem and then check how I do it and back and forth like that. So the main idea, once again, for solving equations is you want to get x by itself on one side and everything else on the other side. And we do that by the different properties of an inequality. We can addition property of inequality, subtraction property of inequality, multiplication property. But the basic idea of these properties is that they, as long as if you do something to one side of the equation, as long as you do the same thing to the other side of the equation, then the equation remains equivalent to your original equation. So like, for example, in this one here, number 1, my first goal is to get the x by itself, but notice there's x's on both sides of the equation. So I have to get them together first. So my first move here is going to be add 7x to both sides. And when I do that, I get 12x on this side and a 6 on that side. So now I have all the x's together. And so then I just have to undo whatever's done to the x's. So this is 12 times x. So to undo that, I divide by 12 and I get x is equal to 1/2. And that is the solution to this equation. That's the number that I can replace x with that'll make this equation true. Okay, so moving right along here, number 2, same idea. Notice we have x on both sides of the equation. I'm not going to be able to touch this side yet. The other side, I'm going to simplify it, which we're good at now because we've been working on that quite a bit. So that would be x minus 8 minus 4x. I distributed the negative 4 through. And that would be 7 minus 3x is equal to negative 8 minus 3x, because I add the positive x and the negative 4x together. And now I'm ready to get the x's together. So to do that, I'm going to add 3x to both sides. Whoops. We get 7 on this side and negative 8 on that side. So remember I warned you about this in the other video. When I get, so the x's have disappeared, and I'm left with a 7 on one side, negative 8 on the other side. This is an equation that is never true. So this is what we call, I would just say there's no solution to this equation. And I think XYZ says it's a contradiction, calls it a contradiction. Okay. But the main idea is this is telling me that there isn't any number I can replace x with that'll make this equation true. Okay, number 3. Once again, we're going to simplify first, so that would be 24x minus 30 and 24x minus 30. And now here's the opposite of what we just experienced. You can see that they're the same thing on both sides. If you didn't notice that, you would have subtracted 24x from both sides. And you would have got negative 30 equals equals negative 30. And see how this one, you end up with an equation that's never true. This one, I end up with an equation that's always true. So this is what we call an identity. Identity is an equation that you can replace x with anything you want, and it'll still be true. So no matter what I plug in for x, this will be a true equation. Okay, moving right along, this is going to simplify both sides this time, so that'd be 15x plus 25, and this is going to be 15x plus 3. That's supposed to be a plus there. And subtract 15x from both sides. I end up with 25 is equal to 3, and so that's a no solution, because I end up with the equation that's not true. Okay, a couple more like this. You can see right away from the beginning, notice there's a 2x on this side, 2x on that side, and then a 5 and negative 3. That's not going to work. But we'll just go ahead and carry it through. Minus 2x from both sides, and we get 5 is equal to negative 3. That's not true. So no solution. And one more, I think here we got a 3x plus 3 minus 5 is equal to 3x minus 2. So this side would be 3x minus 2 equals 3x minus 2, and that we can tell is going to be identity. identity. Because they're exactly the same. Okay, hopefully we're done with those. So on this one, I have a negative 2x equals, and a negative 3x and a negative 2x, that would be a negative 5x plus 12. So this time, when I add 5x to both sides, I'm trying to get the x's together, right? I get 3x is equal to, and that of course is 0, 12. This is going to have a solution. If I divide both sides by 3, I get x is equal to 4. And that is my solution. Okay, over here, I'm going to distribute the 8 through, so 8 times b is 8b. 8 times 1 is positive 8, plus 4. On this side, I have 3 times 2b, which would be 6b. 3 times negative 8, which would be negative 24. And then minus 16. Notice I'm only multiplying the 3 by this and this, because that 16 is outside the parentheses, right? Okay, so then I have 8b plus 12 is equal to 6b minus 40. So I'm going to get the b's together, so I'll subtract 6b from both sides. And I get 2b plus 12 is equal to negative 40. Subtract 12 from both sides, I get 2b is equal to negative 52. And then finally divide both sides by 2, and I get b is equal to negative 26. Okay, here I'm going to distribute the 6 through. That would be 12 plus 6y. Distribute the 3 through, and I get 9 minus 3y. And once again, get the variables together. So that would be add 3y to both sides. And I get 12 plus 9y is equal to 9. Subtract 12 from both sides, and I get 9y is equal to negative 3. Divide both sides by 9, and I get y is equal to negative 1/3. Okay, once again, we start off by, going to simplify anything that can be simplified. 2 times y is 2y. 2 times negative 5 is negative 10. Of course, you don't multiply the 2 by that 2 because it's outside the parenthesis. Then we get 4y is equal to 2y minus 12. Now we're going to get the y's together after we're done simplifying. So subtract 2y from both sides, and we get 2y is equal to negative 12. Then we divide both sides by 2, and we get y is equal to negative 6. And that's my answer. That's my solution. Again, just do a little bit of simplifying. 6x minus 9x is negative 3x minus 4. And that's negative 2x minus 2. Add 2x to both sides, and I get negative x minus 4 is equal to negative 2. Add 4 to both sides, I get negative x is equal to positive 2. And of course, I don't know what I want to know what x is, not negative x. So I just multiply both sides by negative 1, and I get x equals negative 2. Number 12, we're going to multiply negative 2 times 2x, that'd be negative 4x. Negative 2 times 3, that'd be negative 6. Negative 4 times x, that'd be negative 4x. Negative 4 times 1, that'd be negative 4. And of course, I don't multiply negative 4 times negative 2, that's outside the parentheses, so he just comes down. Then I have a negative 4x minus 6 is equal to a negative 4x minus 6. Oh, looks like the identity again. Yep, so that would be identity. Again, because the two sides of the equation are exactly the same. Remember, identity means that I can plug any number 1 in for x and the equation will be true. Okay, here we just have to distribute the negative 3 through, so that would be negative 3y, negative 3y minus 9 is equal to 2y plus 3. So if I add 3y to both sides, I get negative 9 is equal to 5y plus 3. Then subtract 3 from both sides. I get negative 12 is equal to 5y. divide both sides by 5, and I get negative 12 fifths is equal to y. Okay. Distribute the 2 through, that would be negative 6a plus 10. Distribute the negative 4 through, that would be negative 4a, minus 16. And then get the x's together, so I'll add 6a to both sides. I get 10 is equal to 2a minus 16. Add 16 to both sides, I get 26 is equal to 2a. Divide both sides by 2, and I get 13 is equal to a. Okay. Now we got some decimals. Of course, you could just do the same thing with, you could just treat these like numbers because they are. If you don't like decimals, you could just eliminate the decimals by multiplying everything by 100. The reason why I say 100 is because I have one decimal here that has 2 places. This one only has 1, that only has 1. So I could, if it wasn't for that one, wasn't for the 0.05, I could have just multiplied by 10. So if you're not comfortable with the decimals, although if you multiply by 100, you're going to get numbers bigger, but here we go. So I'm going to multiply everything by 100. So that would make, and notice on this side, there's just one term here really. So if I multiply the 1.2 by 100, I'm going to get 120. But I don't multiply the 3x plus 2 by 100 because it's being multiplied by 100 by this one, right? If I multiply that by 100, I get 320x. Multiply that by 100, and I get plus 5. Then we're going to go ahead and multiply the 120 through. 120 times 3 would be 360x. And 120 times 2 would be 240. And this is 320x plus 5. If I subtract 320x from both sides, I get 40x plus 240 equals 5. And then I subtract 240 from both sides, I get 40x is equal to negative 235. Divide both sides by 40, and I get x, I'll have to come back up here, x equals negative 235 divided by 40. 5 will go into both of those, so I get x equals negative 47 over 8. There we go. Now number 16, notice it's just all of them just have one decimal place, so I'm just going to multiply everything by 10, and I get 3x plus 2 is equal to 4x minus 3. Subtract 3x from both sides, and I get 2 is equal to x minus 3. Add 3 to both sides, and I get 5 is equal to x. Okay, now we're moving into some fractions. When you have fractions, this makes me think of complex fractions. I don't really like dealing with a lot of fractions, so you can eliminate them from the very beginning by multiplying both sides of the equation by a common denominator. So if I look at this first one, the common denominator is 12. And so if I multiply both sides by 12, the 12 and the 4 cancel, leaving a 3. So that's going to be 9t. And here the 12 and 3 cancel, leaving a 4. So that would be 8. So then I divide both sides by 9, and I get t is equal to 8/9. Common denominator in this one is 15. So if I multiply both sides by 15, that cancels, leaving a 5. 5 times 2 is 10. And here, 15 cancels the 5, leaving a 3. So that'd be negative 9t. Divide both sides by negative 9, and I get negative 10/9 is equal to t. Go ahead and leave it as the top of your fraction rather than change it into a mixed number. Okay. Wait, where'd that 12 come from? What's that? That's weird. Okay, so this one, we're going to multiply both sides by 12. So here, that would be negative 10x, and multiply that by 12, that would be 9. So x is equal to negative 9/10. Over here, I'm going to multiply both sides by 4. So that would be 3x is equal to 2. which means x is equal to 2/3. Okay, running up here, there's only one fraction here, so I'd probably just multiply both sides by 5. So that would give me 2 times x minus 2 equals negative 15. Again, notice I just multiply this side by 5 and that side by 5. The 5 cancels out. Since it's all one terms, it cancels out for it. So then I'm going to divide both sides by 2. So that'd be x minus 2 is equal to, oh wait, I guess I could distribute. Now, I should pause it for a minute. You can go two ways here. You could divide by 2 right now and then add 2 to both sides, or you could distribute the 2, or in other words, simplify this side and then go from there. So since I haven't done one of these yet, I'm just going to divide by 2 right now. So that goes x minus 2 is equal to negative 7.5. Then I could add 2 to both sides, and that would be x equals negative 5.5. Okay. Once again here, I could multiply by both sides by 4. That would give me 3 times 2x plus 1 is equal to 8. This time I'm going to do it the other way. 3 times 2x would be 6x plus 3 equals 8. So then I subtract 3 from both sides. That would be 6x is equal to 5. Divide by 6 and I get x equals 5, 6. Okay, over here, same idea, multiply both sides by 3, so I get 2 times 3x plus 1 equals 15. And I'll distribute again, so that'd be 6x plus 2 equals 15. Subtract 2 from both sides, and I get 6x is equal to 13. Divide by 6, and I get x equals 13, 6. That's fun. Okay, now here's one that's just crazy with fractions. So I look for the common denominator. There's 3 fractions there. The common denominator would be 10, because we need a factor of 5, and we need a factor of 5, which we already have, and we need a factor of 2. So I'm going to multiply every term by 10. So I'm going to have a little 10 times there, 10 times there, 10 times there, 10 times there, and a 10 times there. So 10 times 1/2 would be 5. 10 times 2/5 t would be 4t. 10 times negative 1 is just negative 10. 10 times 1/5 t would be 2t. And 10 times t would be 10t. Now the fractions are all gone, so we're going to simplify both sides. The negative 10 and the 5 will combine to give me a negative 5, and the 2t and 10t would become 12t. And I think I'll subtract 4t from both sides, so I get a negative 5 is equal to 8t. Divide both sides by 8, and I get negative 5/8 is equal to t. Okay. Common denominator here is 15 this time, so multiply everything by 15. So that would be 3m plus 10 minus 30 equals 15m minus 6. Simplify. 3m minus 20 is equal to 15m minus 6. I'll subtract 3m from both sides, and I get negative 20 is equal to 12m minus 6. Add 6 to both sides, and we get negative 14 is equal to 12m. Divide both sides by 12, and I get negative 14 over 12 is equal to m. But of course, I can reduce that. So that would be negative 7 over 6 is equal to m. Okay, one more fraction here. Multiply everything by 12, and that would be negative 3w minus 36 is equal to 12w plus 4. Add 3w for both sides, and we get negative 36 is equal to 15w plus 4. Subtract 4 from both sides, and we get negative 40 is equal to 15w. Divide both sides by 15, and I get negative 40 divided by 15 is equal to w. Of course, I can reduce that by 5s. That would be negative 8. Whoops-a-daisy. That would be negative 8 over 3 is equal to w. Finally, we have a couple of decimals here. This looks like it has at least one with 2 decimal places, so I'm going to multiply everything by 100. So that would be 350x plus 800 is equal to 1,824 minus 590x. So add 590x to both sides, and we get what? X is 0, and 9 plus 5 is 14. 5, 8, 940 plus 800 was 1824. Subtract 800 from both sides, and we get 940x is equal to 1024. Divide both sides by 940, and we get x is equal to 1024 over 940. Let's see, we can reduce that by 4. That would be 2, 5, 6 over, reduce that by 4, and that would be 2, 3, 5. And that might be it. 11. Yeah, I don't think that's going to only be divisible by 2, and that's not divisible by 2, so that's all she wrote. And this last one, I'll do everything by 100, so that would be 30x. Oh, shoot. Did I do that wrong? Yep, I did. Doggone it. So we're going to erase that. Glad I caught it before too far. Erase that, erase that, erase that, erase that. That should have been 80, not 800. They only multiplied by 100, right? Yeah, okay. So let's try that again. So this would be 940x. That's going to be subtracted 80, so that would be, what, 1764? All right. 8 from 2, no, 44. Subtracting 80 from 124 would be 64. Yep. No, I mean 84, yep. Okay. So then we'll divide by 940, and I get x is equal to 1744 over 940, and that again is divisible by 4. So that would be, if we're going there 4 times with 1 left over, going there 3 times with 2 left over, and 6. And 4, we're going there twice with 1 left over, and 3 times with 2 left over, and 5. That's definitely not divisible by 5. Therefore, and this is 5 times 47. That's not divisible by 47, so I think we're done there. Okay, back here, multiply everything by 100. That'd be 30x minus 24 is equal to 36 plus 52x. Subtract 30x from both sides, and I get negative 24 is equal to 36 plus 22x. Subtract 36 from both sides, and I get negative 60 is equal to 22x. Divide both sides by 22, and I get negative 60 over 22, oops, is equal to x, which means I can't divide that by 2, so that'd be negative 30 over 11. All right.